All right, hey y'all, so we are moving on to interpreting graphs and storylines of functions, okay? So we have 3 different goals here. Go ahead and read those goals to yourself before proceeding with this video, all right? So, already completed memory jogger, we are moving on into this dog run activity. So it says on the board, but I'm going to show y'all right here, there are 5 pictures of a dog taken at equal intervals of time. So this is the picture of the dog. So that's the first one. It's far away. And as it keeps moving, the dog is getting closer to us, right? So from here, it starts far away. It's like in the background back there. And it starts to get closer and closer as time goes on. So we have 2 people, Diego and Lynn, and they drew different graphs to represent the situation. So that's Diego's and that's Lynn's. They both use time as the independent variable. Remember, the independent variable is X. That goes on the X axis, right? What do you think each one used for the dependent variable? Explain your reasoning. So I know, okay, time goes here. And I know for Lynn, time goes here, right? So let's look at the pictures again. So the dog is here in the first picture. It's kind of in the same spot in the second picture, right? Third picture starts getting closer, 4th picture closer, and 5th picture a lot closer. So what do we think Diego used? So Diego's is down here. It starts down here and it's constant. That kind of represents the first 2 images where the dog is at the same spot all the way in the back, right? And then it starts to move and get further. All right. With Lynn, it starts up here somewhere. And then it starts and gets closer. So it says, what do you think each one used for the dependent variable? So what do we think they used for y? Because remember, y is the dependent variable. Y is the dependent variable. So we got to figure out, okay, what did they use? So Diego said, okay, the dog is really close. And then it starts moving further. So it could be distance traveled, right? How far did the dog go? Traveled. All right. And then for Y, we could for Lynn, it starts to go down. So it seems like as time goes on, the dog is getting closer to us. So we could say distance away from us. So I'm going to turn my paper so I can write that better. So distance away from, let's say, me. All right. That's how you have to read the graph. Because if we look at Diego, okay, so as time goes on, first time it's like kind of the same distance and then it travels a lot further. But with Lynn, she's saying, okay, the dog is starting away from us up here. It's not moving, but then it starts to get closer to us. So the distance away from us is decreasing, right? That's how you have to interpret the graph. So let's look at this next activity. It says, for each situation, name the independent and dependent variables. Pick the graph that best fits the situation or sketch the graph if one isn't provided. Label the axes. So Jada is training for a swimming race. The more she practices, the less time it takes for her to swim 1 lap. So Jada is training for a swimming race. The more she practices, the less time it takes for her to swim 1 lap. So my independent variable, I would say, is practice, right? How much she practices. So independent, I'm going to put right here. Practice. Move this over a little bit. Practice. And practice. So the time to swim 1 lap would be the dependent variable. Dependent variable. So I'm going to turn it so I can write time. So again, we have to interpret the graph. So Jada is training for a swimming race. The more she practices, the less time it takes for her to swim. The more she practices, the less time it takes for her to swim. So the more she practices, the less time. So we should have a graph that's going down, right? This graph, it says, okay, if she doesn't practice at all, this is how much time it takes. The more she practices, the more it's going down. So this graph seems to represent the situation. Over here, it's saying the more she practices, the more time it takes her to run. And this one's saying the same thing. It's increasing. So it doesn't make any sense. So let's look at question 2. Andre adds some money to a jar in his room each week for 3 weeks and then takes some out in week 4. So he adds money to a jar in his room each week for 3 weeks. So I would say the weeks is the independent variable. All right, that's the X. I'm going to put amount of money right here. Amount of money. I'm trying to get better with my camera work, y'all. Of money as the dependent, right? Because depending on the number of weeks, so the amount of money depends on the number of weeks that pass by, right? So that's what we're looking at. So he adds some money to a jar in his room each week for 3 weeks and then takes some out in week 4. So let's say at week 0, he has $0. So let's start down here. So as the weeks go by, he's adding more money, right? So the amount of money is going up. However, in week 4, he takes it out. So what should happen? It should go down at some point, right? So that seems like the graph that would work. All right, so now we are going to sketch a story. All right, so create a drawing that shows your response to each question. So here's the story. Noah was at home. He got on his bike and rode to his friend's house and stayed there for a while. Then he rode home again. Then he rode to the park. Then he rode home again. So create a set of axes and sketch a graph of the story. So we have this. So let's do it. So Noah was at home. Okay, let's sketch the graph. So he's at home. So we're going to say right here. Then he got on his bike, rode to his friend's house. So we're going to say, okay, that's going up. Oh, God, y'all can't see that. So he's at home, rode to his friend's house. He stayed there for a while. Okay, so he's stagnant. It's constant. Then he rode home again. So he's back at home, right? He's back at home. Then he rode to the park. Then he rode home again. It didn't tell us that he stayed at the park for a little bit. It just says he rode to the park. Then he rode home again. So there's no constant right there. He might have just turned around and went back home. So this is our axes. Now we're going to... and we sketch the graph of the story. So what could this represent and what could this represent? So this would be time, right? Because as time goes on, things are happening. But what does this y-axis represent, the dependent variable? We know this is home and it's at 0. So that's probably the distance from home, right? So I'm going to write that in as distance from home. All right, that's distance from home. So that's question 2. Based on your graph, is his friend's house or the park closer to Noah's home? Explain how you know. So when he went to his friend's house, it was right here, right? His distance from home was right here. And then when we drew the graph again, we put it right here. So that's kind of the same distance, right? If I drew it higher, it would have been further. The park would have been further, right? Because remember, so this is him biking to his friend's house. This is at his friend's house. This is him going back home, going to the bike, then going back home. Right? So the distance is the same because they have the same y point. So they lie. Their y measure is the same. All right, here's a different activity. I want y'all to do this one on your own and then look at my response, okay? So Elena starts to walk home from school, but has to turn around and go back because she left something in her locker. On her way back home, The second time, she runs into her friend who invites her to the library to do homework with her. She stays at the library and then heads home to do her chores. So which graph fits Elena's story? So let's look at this one. It says Elena starts to walk home from school. So I guess she's almost home, but then she has to turn around, go back to school. Okay. And then it says on her way back home a second time. So this one just goes straight. Okay, so cool. So she left something at her locker, so she has to go get it, right? Then she runs to her friend who invites her to the library. So, sorry. Let me start from the beginning. So Elena starts to walk home from school. Cool. She's walking home, so her distance from home is decreasing. Then she has to turn back around, so her distance from home goes back up. She gets the stuff out of her locker. That's why it's constant. And then she starts walking back home. And on her way back home the second time, she runs to a friend who invites her to the library. So there's nothing constant right here, though. So that's confusing me. Okay. And then she goes to the library. So her distance from home is increasing. She stays at the library for a little bit, and then she heads home. Okay, that's a possibility. Let's look at this table. So let's say she starts at school. She starts to walk home. Cool. But then she has to turn back around. She goes to her locker. She starts walking home. She runs into a friend who invites her to the library. So she goes back down. And then she's at the library. Then she goes back home. So both of these could possibly work, but they would represent different things. So we know the bottom is time. Right? The bottom is time. For this graph, it's her distance away from home, right? Because as she gets closer to home, the closer she gets to distance being away. So I can say distance from home right here. Right? But for this one, it's like moving in the opposite direction. It's like going the opposite way. So instead of distance from home, it would be distance away from school. Because the further she walks, the further she gets away from school. Right? And that is that on that. So the point of this lesson is for you to interpret, okay, what's the independent, what's dependent. Yeah, that's important, but also how to interpret the graphs in general. Because a lot of times they'll give you what the X and Y stand for, and then you'll have to see which graph matches. So you'll be doing that on your practice, all right?